Hello YouTube, iFixItAll here, Team iFixItAll. The crappy first video on this series was one of my objectives for this series was to get the starter replaced, starter relay, and work on these fuse links and determine if I even need to or not. So let's just go over a little tidbits about fuse links and what they do. I'll adjust this and we will get started. Hang tight. Now, some of you may find this kind of stuff intimidating, but it's not that hard. You just got to familiarize yourself with what symbols and shapes are and what have you and what they're trying to convey. This is a schematic of my this is the vehicle application, diagram 1 of 10. Let me get something to point with here. That'll work. So what we're focusing on is this area right here. And we can catch the idea that there is a car battery over here. And once you locate that, then you're looking for something called a starter relay. And you'll notice something labeled starter relay. And then you'll start to try to rationalize a lot of this out. Like, okay, there's a wire that leads over to the battery. That must be my big battery cable. And all that's hooked up to the starter relay. There's a single wire coming off the other side of the starter relay down to starter motor. You start sorting this out and organizing it in your mind. You say, well, there must be an area where the battery cable is hooked up along with a yellow, and a green. And they're all called fuse link. A, B, C, D, whatever. They're labeled with. They're labeled in such a way to where you'll see them referenced in future schematics. What we're going to do is go out there and verify that we are on the right schematic, because we're looking for 3 yellows and 1 green fuse links. There should be a yellow with 4 fuse links, a yellow with 3, and it looks like it's a yellow with a single fuse link, and a home run green fuse link. Notice it travels all the way over to the alternator. Now, Ford people understand the brown-orange leads here, these two, as your alternator output. So you can see as your alternator is turning and spinning and generating electricity, these 2 wires are coming out. And the reason why there's 2 is because you would have to have one big, huge single wire coming out to feed backwards up to this common point to recharge your battery. Okay, so they split out, they come out with 2 conductors that are smaller and more manageable, tie them together at a point, and then create a green fuse link. So as far as the colors of these fuse links, I can't really find a table that tells me the ampacity table for a particular color fuse link, but I'm electrically inclined enough, and I can use my uglies, table 310, 16, or 17. Oh, come on. Yeah, this would be 310, 16. You could use in cable tray or raceway. I think automotive applications, they go free air ratings for wiring, but like for instance right here, a 90 degrees C rating on a 14 gauge wire is good for 35 amps. I would never do that, but hey, it's the code. I think they use free air environment as a guide in automotive applications, because Article 93, I believe of the NEC, dictates who is allowed to ignore the NFPA, like telecommunications facilities, power companies, railways, automobile manufacturers. Did I say hospitals already? Yes, hospitals. They don't have to follow the code. So, having said that, let's go back outside, and we're going to be looking for a pattern. We're looking for 3 yellows and 1 green. One yellow is going to have 4 fuse links. One yellow is going to have 3. And one yellow is going to have 1 fuse link. So there you go. Hang tight. So the purpose of this video, I got my microphone on. It's been screwing up lately. Is to determine, do I need to replace my fuse links or not? I'm going to go through an extra step that I wouldn't do just for the video here. I'm going to disconnect my fuse leads from the starter relay, and I also am going to have to disconnect the I'm going to choose to disconnect the positive battery post, just because it's the right thing to do for this extra step that I normally wouldn't do. By the way, sorry for the audio problem on the first video of this series. The wife and I have determined that it's probably my Bluetooth gets sketchy if there's an internet glitch. And if the internet glitches, Bluetooth will disconnect. I don't know, do you guys have that trouble? Alright, spread this post out a little bit. There we go. Raise that off, and that makes the entire system cold. I'll pull this off for a second. This has become a bane of my existence right here. Tuck that away. Yeah, we'll tuck that back there. That single wire slip-on boot goes to your ignition switch and supplies 12 volt to the coil of the relay. And the relay on the other side of the coil gets its ground through the frame. Then it pulls 2 big contacts together that bridges these 2 studs and sends power down to the starter motor. A single wire. And then the starter motor, since it's mounted to the engine, gets its ground side from the engine harness. Let's find my ratchet and recall what we discussed earlier about the quantity of fuse links and the wiring scheme that diagram was trying to communicate to us. The wiring diagram was saying that we have 3 big yellows and 1 big green, or 3 yellows and 1 green, which represents our fuse links above and beyond the battery post cable. Okay, so we got the big red cable that leads from the starter relay up to the positive battery post. We've got 1 yellow. We've got 2 yellows, 3 yellows, and a green, just like the diagram says. Now if you remember, one of the yellows had 4 fuse links, 1 yellow had 3 fuse links, and 1 yellow had 1 fuse link. So let's sort through them. Here is a yellow that has, whoopsies, put that there. Okay, so here's a yellow fuse, a yellow lead that has 1, 2, 3, 4. These represent 4 individual circuits down here. They do 4 individual things. We could look at the diagram and see what they do, but if you had a particular section of your car that was failing and it wasn't a blown fuse or a bad relay, perhaps it's a blown open fuse link. Fuse links integrate a technology to where they interrupt the circuit. They do a job that goes above and beyond what a normal fuse would do. Let me show you. What they do is they act like a fuse. They protect the wiring to prevent fires, but fuse links, from this point here, this is a splice with heat shrink. This is a splice with heat shrink. But this material right here, the insulation is made of a material that if the interior conductor melts open because you've drawn too much current due to a fault, the wire inside the insulation burns open, but the insulation will maintain its integrity and not melt, and it will help prevent fires. It's a special insulation. Secondary, another thing about fuse links is you've usually got a wire that's a big gauge on one side and a big gauge on the other end for this particular fuse link. But the fuse link will be like 3 or 4 times in wire gauge smaller than the circuit that it feeds. Notice that's a black yellow and it's tapped into, I would say this is like a number 10 gauge right here. But it's interrupted by a fuse link that is, geez, I would probably say that's almost 18 gauge right there. It doesn't make logical sense in the world of electricity, but it is what it is. So here we got a fuse link, a big yellow, that's broken up into 4 branches, feeding 4 individual circuits, and we saw that on the schematic. Here's another yellow fuse link that's branching out into 3 different circuits. And here's another fuse link, yellow, that's going out to 1 circuit, which if you follow the schematic, you'll probably see that it does another branch downstream. See, this is upstream. This is the power company right here. This is the battery. The alternator is actually the real power company. While the engine is running, the alternator outputs power and goes up to this post here and delivers electricity, but it also sends electricity through the battery cable to recharge your battery to the positive battery post. And if your battery's grounded, then that's how the battery gets a ground. Once the battery is full, it goes into something called open circuit condition, to where it's no longer a load on the alternator. It is not a thing that needs refilled like a bank account, you know. Having some troubles here. I'm going to zoom back a little. Hopefully that works out. So what I've shown everyone here is that I have accounted for the yellow fuse links. There's 3 yellows. Now here's a green fuse link that goes down a separate path. And we discussed earlier that the green fuse link is receiving recharge from the alternator up the green fuse link and up to this stud right here, which delivers electricity out through the battery cable into your positive battery post. So the objective of this video is to find out, do I need to replace my fuse links? So I'm going to reconnect everything back up, and I'm going to take a couple of measurements. I'm going to dress these in a little differently because before they were kind of twisted up. All right, there's that. There's not too much to say about fuse links other than I want you to understand that when would you decide to use a fuse link? Well, you already know when you want to use a circuit breaker. You want something to disconnect power when there's a fault. But what do you do when you have situations where that wire is drawing different amounts of current depending on what you choose to use in your vehicle? And when those items kick on, how much inrush is that back on the overcurrent protection device, like the fuse or the breaker? So when you have scenarios where you can't control, like the alternator is not always going to put out the same amount of current to recharge the battery or the same amount of current to work the car, because there are conditions where you have a dead battery and that alternator under normal conditions is only needing to supply 20 amps worth of current, even though it's a 150 amp alternator. You could have a dead battery and get a jump start, and now your alternator is not only supplying you with 20 or 30 or 40 amps to run the car, but it's also sending out about 50 amps to recharge this battery. And that's all strain on the fuse links. All right, so here we go. There's that fuse link. So fuse links give you wiggle room to allow for those volatile scenarios where you're not having a constant, predictable amp draw all the time, no matter what case there is. Now, in the world of circuit breakers, those are more calibrated. They will trip at a certain amount of time, at a certain amount of amperage demand. Fuses will blow open, but they're not necessarily extremely calibrated to blow at the same amount of fault current, same amount of fault condition. And then you have fuse links, which have a wide bandwidth of what it takes before they really blow wide open. All right, so fuse links are useful in that they allow some degree of stress and strain on the wire harness, just in case it's a false alarm. And, well, you're not going to always draw that much current. This is just a scenario where it's going to be a temporary condition where you're drawing a lot of current for a few seconds and then that load goes away. Whereas if you used a fuse or a circuit breaker, you would have blown your fuse or tripped your circuit breaker. All right, so let me tighten this up. Nope, I didn't think so. It's the same tool I used before. I'm not real sure I like that. By the way, if you have your stock hardware, try to keep it, because they integrate a crimped in washer that spins, so that when you tighten down, you're not spinning the nut against the lugs and ripping them apart. I'm going to try to redress this a little differently if I can. There we go. That'll work. No, I don't like that either. It's always kind of tricky how you want to dress these lugs and offset and stagger them. Alright, I don't mind that arrangement right there. It'll let me flow proper toward the battery. Let me get set up here and hang tight. Let's hook up the battery now. See if we're doing okay on microphone. I hope we are. Okay. The purpose of this video is to determine, do I want to replace my fuse links with fuses? Basically just cut out these little fuse links because they're such tiny wire, and I've been going through starters and relays to a suspiciously higher level than what I expect. Not to say it's a yearly thing, but every 3 or 4 years seems like I've got to, you know, the OEM starter relays last a lifetime, which I mean, 20 years. But then you get these aftermarket things and they're just good for a couple of years and something's jacked up. It's just lack of confidence in manufacturing anymore. So what I'm going to do is use my meter, and I'm going to take some readings, and I'm going to, let's first find out what our baseline voltage is of our battery. Let's get the screwdriver out here before I forget it. And let's first set our meter up to where you guys can see it. Let's see. See if that'll be good for you. That won't. That won't. Let's see if that'll be good. I don't know. Looks like you have a wire blocking you. You do. I'm going to go to DC volts. Okay. Let's see what our battery voltage is. Go from my negative to my positive. We're reading 12.74. Something's bugging me about this entire setup. Hang tight. Let's work with that until it's a problem. So I've got a adapter that I'm going to use to translate my negative ground cable to a way where I can hook it up and clamp it directly to battery ground. I'm going to be right here. Let's hope I got a good ground. Let's just leave that right there. Let's make sure we've still got 12.74. Okay. Now I'm going to translate my positive battery cable to a tool called Power Probe, to where it has a device on the end of it, a little pointy bit that comes out and pierces the conductor. See if I can show that to you. Maybe you can see that. Okay. I'm going to plug that into my battery cable. And I need to validate we have I'm going to do that. Double check. Okay. So yeah, I'm making a good connection right here. And I'm just using this to finagle fuck the reading. I mean, to make sure the reading is showing up proper. And I'm getting 12.74. Alright. The closer we are to the battery of the alternator, that's like the power company, okay? So currently right now in this condition, the truck's not running, so the battery is my power source. So I know my red cable is sitting on top of all of these fuse link connections. And with that being said, I'm going to see what the voltage is after the fuse links down here. So I got several wires that I can temporarily pierce. And the meter's jumping around right now, but it's showing millivolts. I could probably zero that out, but I'm not concerned with it. What I'm going to do is go through here with my meter, and I'm going to measure each individual downstream circuit. Downstream meaning headed toward the far end equipment that fuse link operates. I'm going to measure all the downstream circuits to see if I have the same battery voltage. And so I'm adjusting. Looks like I'm zoomed in, and I don't know why. Let's just try that. Here's the first downstream circuit. I'm going to tighten up, and I'm looking for 12.74. So I have reason to believe that fuse link, and I'm wiggle testing it right now, and the voltage isn't dropping or moving around, so I'm going to call that good. Alright, so I'm going to set that one aside. Go to this fuse link right here, and I'm looking for the voltage to remain stable and be the same as battery. I've got 12.74, and I wiggle test the fuse link around, and the voltage is not changing, so therefore I don't have any reason to replace that yet. Go to this next wire. I'm just getting them all. I'm going to go to this one, pierce it, 12.74. I wiggle test the fuse link around. Basically, as I wiggle test, what I'm looking for is an intermittent connection or a poor connection. That might be a loose connection due to you would never notice it unless it's just, it comes and goes. And an engine running, translating vibration over here could be one of those reasons why it would be intermittent, constant shaking. All right, so that one's good. Moving on to the next fuse link. Temporary tap into it. Oh, what's going on here? Looks like I missed. Looks like I did not connect. There we go. Center up on it. 12.74. Wiggle test the fuse link. I don't get my voltage jumping around. It's not moving around. Okay. It looks good. Going to another lead. I just bumped the camera. Can't recall if I did this fuse link or not. Should only have 8 over here to do. Tap this one. 12.74. 75. Wiggle test the fuse link around. Nothing. Everything looks fine and stable. Moving on to another fuse link. 12.74. Wiggle test. Steady Eddie. Moving right along. Here's a bigger cable. 12.74. Wiggle test. Holding steady. This one looks like that single yellow. Now, if you're worried about that little pinhole I'm putting in it, well, that's the world of troubleshooting, you know. After you do the piercing, you massage it with your thumb and try to move that insulation around, and, you know, it'll be fine. Yeah, there will be corrosion that gets in there one day. The proper fix to that is put something over it to keep water and stuff out, but it's my pickup, so. All right, so now the next test I could do is over here on the alternator. We know that big green fuse link over here I have not tested yet. And it leads up to the alternator. Over here on the alternator, I have 2 big orange conductors. I think I could disconnect the alternator and test it, but I think I'm just going to hook in to the wiring and zoom you all in, and I think you should be able, or could be able, to see that. Hang on, let me reposition you. Now, right here and right here, these 2 wires, these 2 big, this one and this one, that's my output, alternator output. So I'm going to get in there and check my battery voltage. I can clip around it. With this big hog of a device. All right, there we go. I'll pierce it. I'm hooked in, and my meter says dang it, 12.74. And there's my connection. Now I'll go to the top wire directly above it. Let's see if I can get over that. .74 again. So what I've learned here is if it ain't broke, don't fix it. So I'm going to leave my fuse links alone. I'm going to slide my battery back over. Let me pull this meter out of here. Undo this. Power probe. Christmas is coming up. Invaluable tool. Get a whole set for your hubby. Ladies, this is a good gift. You might even find them on sale. It's always neat to be able to temporary tap into a circuit to see what it's doing while you're trying to measure it. Very useful. Alright, so how much garbage do I need to get out of the way to consider this clear? Clear. Put those in my pocket. Put those down. Get that out of the way. Okay, meter leads. Alright. Scoot the battery back over. Because I don't have hold down straps. Okay. And I'm thinking I'll come back in here and get these fuse links wrapped. Because they have no protection to keep them from bumping up against the battery. If you haven't noticed, when I buy a battery, and you should start doing this too, get you a little sandwich sack or something and put your receipt in here, just in case you lose track of when you bought this thing. This one's actually 12 of 21. And that matches the, well, that's going to be a manufacturer date, so I had to have bought it after 12 of 21. Alright. New starter relay. All fuse links that power the entire truck for everything the truck does is appearing to function proper. The output of the alternator, those leads, seem to be sufficient. And as far as voltage drop, I was looking for a difference in voltage and I didn't get one. Nothing else to report here. Nothing else to see other than I can start it up, but there's not going to be any difference from when I started it up on the first video. So, alright guys, you have a good day. Hope that learned you something or two, and you take her sleazy. See ya, bye.